A wall made from dirt keeps your home at a stable, comfortable temperature year-round with no heating bill and no cooling bill. That is not a theory. The Anasazi built this on the Colorado Plateau 1,000 years ago, and their structures are still standing at Mesa Verde today, a UNESCO World Heritage Site you can visit. National laboratories have tested rammed earth walls and published the results. Interior temperature reductions of 15 to 20 degrees below outside air in summer, and heat retention through cold nights without any active heating system. By the end of this video, you will have the complete step-by-step build guide, from soil testing to finished wall. Every material, every cost in your country, every mistake I have seen people make, and exactly how to avoid them. Here's why it works before we build it. Because understanding the physics is what lets you troubleshoot problems yourself, instead of watching videos every time something goes wrong. Rammed earth walls have a property called thermal lag. Heat hitting the outside surface of an 18-inch thick rammed earth wall at noon takes 10 to 12 hours to travel through to the inside surface. By the time that heat arrives indoors, it is midnight. The outside temperature has already dropped. The wall is releasing stored daytime heat into your living space at exactly the moment you need warmth. In summer, the same lag works in reverse. Cool overnight temperatures charge the wall. The wall slowly releases that coolness through the hot afternoon, keeping your interior significantly below outside air temperature without a single watt of air conditioning. The specific heat capacity of rammed earth is approximately 840 joules per kilogram per degree Celsius, comparable to concrete. An 18-inch wall weighing 150 kilograms per square meter stores enormous thermal energy per unit of wall area. This is not an alternative science claim. It is the same thermal mass principle that makes concrete floors warm in passive solar homes, and that makes stone castles cool in summer. The Anasazi scaled it into a complete building system 1,000 years before we named the physics. One important honest point before we build. Rammed earth performs best in climates with significant day-night temperature swings, desert, semi-arid, and Mediterranean climates. In climates with long cold winters and minimal day-night swings, northern Canada, Scandinavia, Russia, rammed earth needs to be combined with external insulation to perform well in the coldest months. Know your climate before you build now. Materials and costs. Pricing first, because this channel's audience is global and a single dollar figure is not honest. The complete materials for one room of rammed earth wall, approximately 100 square feet of wall face area at 18 inches thick, cost the following by region. In the US, $180 to $250. In the UK, $160 to $20 keys. In Canada, $200 to $270 Canadian. In Australia, $190 to $260 Australian. In Germany and Western Europe, $190 to $260 equivalent. The primary costs are Portland cement, formwork lumber, and tools. The earth itself is either free from your site or $20 to $40 from a landscape supplier. Here is the complete list. 1. Earth. The ideal composition is 70 to 75% sand and gravel, 10 to 15% silt, and 10 to 15% clay. The clay is your binder. Before sourcing anything, test the soil on your site. Take a handful of subsoil, not topsoil, which has too much organic matter, squeeze it firmly into a ball, and drop it from shoulder height onto hard ground. If it holds together on impact, your clay content is sufficient. If it crumbles to powder immediately, your clay is too low, and you need to add clay-rich subsoil from elsewhere. If it flattens like clay and does not break at all, your clay content is too high and needs more sand mixed in. Cost, free from your site in most cases, are $20 to $40 for a truckload from a landscape supplier. 2. Portland cement for stabilization. You will mix cement into your earth at 5 to 8% by dry weight. This is what transforms raw compressed earth into stabilized rammed earth with structural integrity and weather resistance. For 100 square feet of 18-inch thick wall, you need approximately 8 to 12 bags of Portland cement. Cost, $8 to $50 per bag depending on region. Total cement cost, $65 to $120. 3. Formwork lumber. You need 2-inch thick planks for your form panels and 4x4 posts for uprights and bracing. The formwork contains the earth while you compact it and must resist significant lateral forces without deflecting. For 100 square feet of wall, you need approximately 60 linear feet of 2-inch plank and 8 posts of 4x4 at 4 feet long. Cost, $60 to $90 depending on region. 4. Form ties and hardware. Steel form ties hold your 2 form panels at the correct wall thickness apart during compaction. These are either purchased as purpose-made rammed earth form ties at $2 to $4 each, and you need one every 2 feet horizontally and every 18 inches vertically, or fabricated from threaded rod with washers and wing nuts. Cost, $20 to $35 for one room of wall. 5. Tamping rod. A steel bar 1.5 inches diameter and 4 feet long with a 4-inch diameter flat steel plate welded to the compaction end. Any metal fabrication shop can make this in under 30 minutes. Cost $25 to $45 depending on your region and whether you supply the steel yourself. This is your primary compaction tool for the entire project. 6. Breathable silicate masonry sealer for the finished surface. This protects the wall from water erosion while allowing moisture vapor to pass through. Critical step that most first-time builders skip. Do not skip it. Cost $25 to $40 for 1 room of wall surface. Total for 1 room of wall area, $195 to $330 depending on region and whether your site soil is suitable. Foundation and site preparation. This step is where most rammed earth failures begin. Water erosion at the wall base from rain splashback is the #1 cause of long-term rammed earth deterioration. Get the foundation right and your wall lasts centuries. Get it wrong and you will be repairing the base within 5 years. Step 1. Excavate your foundation trench 12 inches deep and 10 inches wide along the full length of your intended wall. Compact the trench base with your tamping rod or a hired plate compactor. Any loose or soft spots in the trench base will allow differential settlement that cracks your wall above. Step 2. Pour a concrete strip foundation, filling the trench to ground level plus 6 inches above finished ground level. That 6 inches of exposed concrete above ground is your critical protection zone. It keeps the base of your rammed earth wall elevated above rain splashback. Use a concrete mix of 1 part cement to 2 parts sand to 3 parts aggregate, standard structural mix. Allow 7 days of curing before setting formwork on top. Step 3. Once the foundation is cured, lay a damp-proof course on the top surface of the concrete before your formwork goes up. A single layer of heavy polyethylene sheet or bituminous membrane prevents groundwater from wicking upward into the wall base by capillary action. Overlap any joins in the membrane by 6 inches and seal with waterproof tape. Step 4. Plan your roof overhang before you build the wall. A rammed earth wall needs a roof overhang of at least 24 inches beyond the wall face to intercept rainfall before it hits the wall surface. If you are adding a rammed earth wall to an existing structure, check your existing overhang distance now. If it is less than 24 inches, plan a gutter and extended fascia board before the wall goes up. This is not optional. It is the permanent weather protection your wall depends on. Building the formwork. Good formwork is the difference between a wall that builds efficiently and a frustrating day of leaks, deflection, and misalignment. Step 1. Cut your form panels to the height of your first form lift. Standard first lift height is 24 inches. This gives you a manageable working height for compaction while allowing good progress per session. Cut panels from 2-inch thick structural lumber at 24 inches wide and the full horizontal length of your wall section. You need 2 panels, 1 for each face of the wall. Step 2. Position your first pair of panels on top of the damp-proof course with the interior face of each panel separated by exactly your target wall thickness, 12 inches for moderate thermal mass or 18 inches for maximum thermal mass. Use a measuring tape and a spirit level on both panels before fixing anything. The panels must be parallel, plumb, and at the correct separation along their entire length. Step 3. Fix your form ties through both panels at the spacing specified above, then every 2 feet horizontally and every 12 inches vertically. Thread the tie rod through both panels, add a washer and wing nut on each exterior face, and tighten firmly. The form ties prevent the panels from splaying outward under compaction pressure. Do not underestimate this force. Insufficiently braced formwork will bow outward during compaction and produce a wall with varying thickness. Step 4. Brace the outside of each panel with diagonal timber braces running from the top of the panel to stakes driven into the ground at a 45-degree angle. Space these braces every 4 feet along the panel length. These diagonal braces prevent the panels from tilting inward or outward under compaction. Tug the top of each panel hard after bracing. It should not move at all. Step 5. Fix a horizontal wailing board across the top of each panel connecting all vertical upright posts. This wailing board ties the panel tops together and prevents any spreading or separation at the top during compaction of the upper layers. Before adding any earth, apply a light coat of used motor oil or commercial foam release agent to the inside face of both panels. This prevents the rammed earth from bonding to the formwork and allows clean panel removal after compaction. Preparing your earth mix. This is the most critical technical step in the entire build. Incorrect moisture content causes more rammed earth failures than any other single factor. Step 1. Combine your subsoil and Portland cement in your cement mixer or on a tarp. Add cement at 6% by weight of dry earth, approximately 120 kilogram bag of cement for every 330 kilograms of dry earth. Mix dry for at least 3 minutes until the cement is uniformly distributed throughout the earth. Uneven cement distribution creates weak zones in the finished wall. Step 2. Add water gradually while continuing to mix. You are aiming for optimal moisture content, the point at which the earth mix compacts most efficiently and achieves maximum density. The correct amount varies with your specific soil composition, typically 8 to 12% water by dry weight, but testing is more reliable than calculation. Step 3. Perform the drop test after every addition of water. Take a tennis ball-sized handful of the mix and squeeze it firmly in your closed fist. Open your hand. The ball should hold its shape without crumbling and without sticking to your palm. Now drop it from shoulder height onto a hard surface. Correct moisture. The ball breaks into 3 or 4 large pieces on impact. Too dry. The ball crumbles to powder on impact. Add more water in small amounts and retest. Too wet. The ball flattens without breaking. Add dry earth and retest. This test takes 30 seconds and it is your most important quality control check in the entire project. Step 4. Once you have reached correct moisture content, do not allow the mix to sit for more than 45 minutes before use. Portland cement begins its initial set within 45 to 60 minutes of contact with water. Mix only what you can compact within that time window. In hot weather or direct sun, this window shortens. Mix smaller batches more frequently. The compaction process. This is where the wall is actually built and where the quality of your final product is determined. Compaction is physical work, but the technique is more important than the force. Step 1. Shovel your prepared earth mix into the formwork in a layer of no more than 4 inches of loose material. Do not exceed 4 inches per layer. Thicker layers produce insufficiently compacted lower sections that create weak horizontal planes in the finished wall. 4 inches of loose material compacts to approximately 2.5 inches of dense rammed earth. You are building the wall roughly half the speed it appears. Step 2. Distribute the loose layer evenly across the full width and length of the form using a short-handled shovel or gloved hands. There should be no areas thicker or thinner than the target 4 inches. Uneven layers produce uneven compaction. Step 3. Compact the layer using your tamping rod. Work in a systematic grid pattern across the entire layer surface. Do not compact randomly. Start at one end and work across in rows, overlapping each strike by approximately 2 inches. Apply firm vertical strike. Then lift the rod 12 to 18 to rise to 18 inches and drop it with the weight of your arms, adding downward force. Do not just drop it. They actively push down through the strike. Consistent force matters more than maximum force. Step 4. Listen and feel. After 10 to 15 strikes per square foot, the tamping rod will start to bounce back rather than sinking into the material. When the rod gives a ringing metallic bounce on impact rather than a dull thud that sound tells you the layer has reached maximum practical density, this is the completion signal for each layer. Moving to the next layer before hearing this change means your compaction is insufficient. Step 5. After completing compaction of each layer, use a nail or a pointed piece of rebar to scratch the top surface of the compacted layer with a crosshatch pattern of grooves approximately half an inch deep. This scarification creates a mechanical key between layers. Without it, your layers can delaminate, separating horizontally under stress. Scarify every single layer before adding the next one without exception. Step 6. Continue adding 4-inch loose layers, compacting and scarifying until the formwork is filled to the top. With 24-inch high formwork panels, this means approximately 9 to 10 compaction cycles per lift. Each lift with manual tamping takes approximately 2 to 3 hours for 1 linear meter of wall, and plan your time accordingly. Step 7. When the formwork is full, remove the form panels carefully. Keep the tie rods in place initially to support the panels. Have a second person support each panel as you remove the ties. The freshly rammed wall does not need the formwork for structural support. It stands independently immediately after compaction. However, handle the panels carefully to avoid chipping the wall edges during removal. Step 8. Move the formwork up for the next lift. Set the bottom of the upper form panels on the top surface of the completed lift and repeat the entire process. The freshly rammed lower section is strong enough to support the formwork and the weight of the next lift without any waiting period. Window and door openings. Most walls need at least one opening, and handling them correctly is essential. For openings up to 36 inches wide, set a timber lintel of at least 2-inch by 6-inch cross-section above the opening before compacting the earth above it. The lintel spans the opening and transfers the compressive load of the rammed earth above it to the solid wall on both sides. Extend the lintel at least 12 inches into the solid wall on each side of the opening. This bearing length determines how much load the lintel can carry. For openings wider than 36 inches, use a 2-inch by 10-inch lintel minimum, or consult a structural engineer for your specific span and load conditions. Set temporary timber props under the lintel during construction to support it while the earth above it is being compacted. Remove the props only after the full wall height above the opening is complete and has had 24 hours to settle. Frame your window or door opening with treated timber box frames that sit inside the opening and provide a fixing surface for the window or door unit. Fix the box frame to the rammed earth using masonry anchors driven into the wall face, finishing the wall surface. After the full wall height is complete, allow a minimum of 28 days before applying any surface finish. This allows the Portland cement to reach full cure strength and allows any minor shrinkage cracking to appear and stabilize. After 28 days, brush the entire wall surface firmly with a stiff bristle brush to remove any loose particles, dust, and surface debris. Inspect every face for cracks. Hairline cracks under 1 millimeter wide are normal and acceptable. They are shrinkage cracks from drying and do not affect structural or thermal performance. Cracks wider than 2 millimeters need to be filled. To fill wider cracks, mix a slurry of your original earth mix, thinned with water, to a thick paint consistency, and work it into the crack with a stiff brush. Overfill slightly and allow to dry for 24 hours. Sand flush with a coarse sanding block. Apply the first coat of breathable silicate sealer thinned 20% with water. This diluted first coat penetrates deeper into the wall surface than full-strength sealer and provides better long-term adhesion. Apply with a large masonry brush, working the sealer firmly into the surface. Allow 24 hours drying time. Apply the second coat at full strength using the same technique. The sealer dries invisible. It does not change the natural earth appearance of the wall surface. This finish protects against water erosion while allowing the wall to breathe, allowing moisture vapor to move through the wall freely, which is essential for the wall's thermal performance.